Let's take a look at question 24 from the May 2016 release version of the Algebra 1 STAAR test. So our function in the graph below is showing us the graph of the function f equals x squared. Okay, so this is the parent quadratic function. So this is the parent quadratic function. Its vertex is at the origin. Okay, so here's the graph, and down below they're asking us which statement about the relationship between the graph of f and the graph of g of x equals 7x squared is true. Okay, so let's go ahead and look at the standard form of a quadratic function. Okay, so the standard form of a quadratic function looks like this. So it's f of x equals ax squared plus bx plus c. Okay, so in this case, of the parent function and the case of our function g, we see that b and c are both equal 0. Okay, both equal 0. That's why those two terms aren't there. So any quadratic function in this form is going to have a vertex, which is this point here. It's either going to be the lowest point of a parabola, which is the graph of a quadratic function, or the highest point, which we also call this would be the minimum value. The y value of this, the vertex, is going to be our minimum value, and if it opens downwards, so if a parabola opens downwards, it would be a maximum. Okay, so all quadratic functions of this form where b and c both are 0, we're just left with the squared term, x squared term, are going to have a vertex at the origin. Okay, so now we're going to look at what this does here. Okay, so see the 7 here? It's in the position of the a. Okay, so that's our a value. Okay, so if we look at our parent function, it's not quite as obvious what our a value is. Okay, so anytime you have a variable with just an x or any other variable, it has an understood coefficient, the constant value in front of the numerical value of the number associated with that variable. Okay, so we have an understood a value here of 1. So let me just go ahead and write here a equals 1. Okay, so what you want to do is you want to take your a value, take the a value, and you want to do plus or minus. Okay, so let's take our a value, which is 1. Let's just write it in general. So you're going to put, let's just use our a value. So you're going to make the opposite of 1, which is -1. And then we're going to put, I'm going to call it a2. Okay, this is our new function. We're trying to compare a1. We'll call this a1 here. Over here, our a2 is 7. Okay, so you're going to take your a2 and see if it's in between -1 and +1. Okay, so this is in between the a value and its opposite. Okay, is this true? So let's go ahead and replace our a2 is 7, and 7 is 7 in between -1 and 1 on the number line. No, it's not, right? So it's 7 is over here. So it's on this side of the number line. Okay, so this is not true. So that means if this was true, if you had this true, then that would mean our graph would get wider. Okay, it'd get wider than the quadratic function we're comparing it to, because it's not in between our a values of our original, or a1 values of the original graph that we're comparing. Then we know that it's going to be narrower. Okay, so our graph's going to be narrower, which is another way of saying vertical, a vertical stretch. Okay, so you want to picture your graph, a vertical stretch. You picture it being pulled upwards. Okay, vertically pulled upwards, and if it opens downwards, it'll be pulled downwards. Okay, so pulled away from the x-axis. Okay, so it's being pulled up away from the x-axis, so it's going to become narrower. Okay, and a vertical, and the opposite, if our A2 was in between -1 and 1, our in between our positive negative version of our A value, then it would be a vertical compression. Okay, so picture that. Picture the graph being pushed down pushing it closer to the x-axis. So when it gets pushed down, it becomes wider, and when we do a stretch, we pull it upwards, and it becomes narrower. So this is one way to systematically check it. So start with your original function that they're giving you. Take your A value, and then you want to put it in a compound inequality here. So you want to put your if our A was -1, you put -1. You put -1 here, and then put +1 here. It'd be the same. So just take the opposite, and then put your A2 in between there and see if it's true. So this is not true. So we know that it's going to be a vertical. It's going to become narrower. It's going to be a vertical stretch. Okay, so that's how you answer that one. So let's look at our answer choices. Let's start at the bottom. The graph of G is 7 units above the graph of F. That's not true. Okay, so our C value here in the standard form, the C value controls going up or down. Okay, up or down. This would need to be a 7 here. If it went up from the parent function. Okay, but our vertex it's the same form as the parent function, where our B and C are 0, so its vertex is at the origin, so it hasn't moved up or down. Okay, the whole graph hasn't moved up and down. Some of our values have become our line has become steeper, but the graph, the whole physical graph, has not been what they call rigid translation. The whole graph has not moved up 7 units. Okay, so we can roll out answer choice J. So let's look at answer choice H. Okay, the graph of G is 7 units below the graph of 7. That would mean here we would have a -7 for our C value, but ours is 0. Okay, so go ahead and rule out that choice. Okay, and now let's take a look at answer choice G. The graph of G is wider than the graph of F. Okay, so this check here is to check to see if it's a vertical compression, which would make our graph wider. Okay, so this was not true. So let's go ahead and circle that. Not true. So it must be the other option, which is going to be a vertical stretch, which makes it narrower, makes our graph narrower. Okay, so go ahead and roll out answer choice G, and all we're left with is answer choice F. Okay, so if both of our A values here was 1, and this was also 1, then it would neither get narrower or wider. Okay, it would stay the same. Okay, if our A values were the same. Okay, so which they're not. Okay, so we went from 1 to 7, and that change from 1 to 7 makes it a vertical stretch, which makes it narrower, or makes our graph narrower when you put it into the calculator. You'll see that you'll graph them two together. Is one way to do it. Graph the two together and see is the new graph G inside or outside. So if it's inside, it's narrower. If it's outside the original parent function here, F, it's going to be, if it's outside, that means it's wider, which means this would have been true. If it's inside, it's a vertical stretch, and it's narrower. So answer choice F is the best one for that one.